trigonal planar geometry. The next category would have 4 electron domains. 4 is known as the tetrahedral. When there are 4 electron groups around the central atom, they will occupy positions in the shape of a tetrahedron around the central atom. The bond angle becomes 109.5 degrees. Thinking this through with this close-up picture, here's a picture on our PowerPoint. This is on the handout. If we have 4 electron domains, the shape of the electron clouds around the central atom will be called tetrahedral. We can see within the tetrahedral electron domain geometry 3 possible molecular geometries based on the number of bonding and non-bonding domains. The tetrahedral shape, if all 4 are bonded, matches the molecular geometry. If we have 3 bonded and 1 non-bonded pair, it's called trigonal pyramidal. And if out of the 4, 2 are bonded and 2 are non-bonded, the shape becomes a bent molecule. There are 3 molecular geometries that share the same electron domain geometry called tetrahedral, based on the number of bonded and non-bonding pairs. The tetrahedral geometry shows 4 electron clouds, electron domains around the central atom. Tetrahedral geometry shows a tetrahedron with angles of 109.5. We might choose to add these onto the chart. We said these were 180 degrees for linear, that a triangle has 120 degrees, trigonal planar triangle. And now we're seeing here 109.5 for the bond angles in a tetrahedron. When there are 5 electron groups, again going back to the handout, we have trigonal bipyramidal. 5 electron domains, trigonal bipyramidal becomes the shape. Notice on our handout that there are 1, 2, 3, 4 possible molecular geometries within the electron domain called trigonal bipyramidal. If all 5 are bonded, it's known as trigonal bipyramidal. If 4 are bonded and 1 is non-bonded, we have a shape called seesaw. If 3 are bonded, 2 non-bonded, it's called T-shaped. And if 2 are bonded with 3 unbonded pairs, it will create a linear molecular geometry. 4 possible molecular geometries when we have 5 electron domains. The electron domain geometry is known as trigonal bipyramidal. The resulting groups of electrons, when there are 5, takes on a shape of trigonal bipyramidal geometry. The positions above and below the central atom are called the axial positions. Placing my paper back on to show the axial positions, notice here in this first picture the B's standing for whatever the ligand is, boron perhaps. The ones that are 180 degrees around, just exactly top and bottom of each other, are called the axial position. Axial. Notice here there are 3 that spin around an equator. These look more like the triangle from the trigonal planar geometry a moment ago. The 3 that are 120 degrees apart are called the equatorial position. Here's what we're saying. Between the equatorial and the axial position, this is a 90-degree bond angle. Between an equatorial to another equatorial, those are 120 degrees for the bond angle. Let me blow that up so you get a closer look. There are, oh, there's my phone. There are two sets of bond angles, straight up and down, 180 degrees from top to bottom, known as the axial position. There are three that create a triangle around the equator of the central atom. A triangle has 120 degrees as a bond angle. From top to bottom would be 180. From a top to an equatorial, the axial to equatorial would be a 90 degrees. So there's two different bond angles in the trigonal bipyramidal electron domain. So the bond angle between equatorial, 120. The bond angle between an axial and equatorial is a 90-degree bond angle. And zoom back out to see those already typed for us there.